Hello everyone, this is the video lecture for Pre-Calculus section 6.3. I'm titling it Revisiting Chapter 5. Almost everything that we're going to be doing here is basically something we've already done. That should be a good thing, I guess, but, you know, here we go. First off, I want to know, before we keep going, when are these trig functions positive? Sine, cosine, tangent, that kind of thing. When are they positive? What quadrants will make them positive? I don't think I actually covered this, so it's kind of good that we're going to do that now. All of the sine, cosine, and tangent functions are positive here. Cosine is positive down here in quadrant 4. Tangent is positive in quadrant 3. And sine is positive there in quadrant 2. So, what do I mean by positive? Well, sine is positive, but that means that cosine is negative and tangent is negative. Cosine, that's positive down here, but sine is negative and tangent would be negative. Here, tangent is positive, but sine and cosine are both negative, and then all of them are positive there. I guess one way to kind of remember, this is kind of weird, ax, I don't know. Just a way to maybe memorize it. So, reference angles, we're going to be talking about that. If you remember, that would be the acute angle with the x-axis. So 6.3.007. Here we go. I got part A, 245 degrees, and they want the reference angle. Reference angle. So blank degrees. Well, this is 180 degrees. And so 245, this is 270 degrees. So it's like down here somewhere. There's my 245. So then my reference angle will be this amount, again with the x-axis, the acute angle with the x-axis. So how am I going to find that? Well, if I did 245 minus the 180, I should get that amount in between. And yes, I do. It is 65 degrees. So there you go. I'm going to do this a couple more times, but if you remember, there was kind of a formula that I made up for you. At least I'm pretty sure I did. I got a theta. I got 180 minus theta. I got theta minus 180. And then I got 360 minus theta. I'm pretty sure that I gave you this formula for reference angles. If I didn't, I'm sorry. I'm currently also working on College Algebra 1414 Chapter 5, which basically does all this again too. So I sometimes get a little bit mixed up if I were to actually give you something or not. So I'm going to show it to you anyways, of course. So that's how you find reference angles. So if you're down here in quadrant 3, like we were having here, you take your angle minus the 180, and there you go. Notice that you can also change these to pi's if you were to do this in radian mode. So part B, 650 degrees, find the reference angle. Well, first off, I know that's way past 360. So I'm going to definitely minus 360 to see if I can get a lesser coterminal angle. So 650 minus 360 is 290. That's definitely within my first revolution. If this is 270 down here, 290 is right here. Following the formula in this particular case, I would then say 360 minus the 290, and, well, I got 70 degrees. There's your reference angle. Last one, negative 145 degrees. First off, it's not even in my first rotation. I need to do something to that, so I'm going to add a 360. So negative 145 plus 360, and I got 215 degrees. Okay. 215, if you do the math, I guess it's somewhere down over here. So then I'm going to use that formula, 180. Oh, whoa, I'm sorry. Wrong formula. 215 minus the 180. And I got 35. Okay, cool. 63011. They want reference angles again, but this time with radians. That's always great fun. So 5 pi over 7. First off, where is that? 5 pi over 7. So I'm thinking this is 7 pi over 7. That's not usual. It's just pi, obviously. It's just pi. 0, pi for 180. But if I were to, have everything divided by 7, let's say, 7 over 7 would cancel, make a 1, therefore it's just pi, right? So this is still legal. This is still okay. So then if I were to cut these up into 7 pieces, 1, 2, 3, 4, 5, 6, 7 pieces, then 5 pi over 7 would be somewhere around right here. So I'm thinking that's going to be quadrant 2. Going back to the formula, this guy, 180 minus my angle. Well, it's not 180 now. It's going to be a pi. So I'm going to say now pi minus the 5 pi over 7. Just like I had said, it's 7 pi over 7 minus 5 pi over 7. 2 pi over 7. There you go. Part B says I got a negative 0.4 pi. That's kind of weird. So if you were to take these in like pi form, I got it 0, of course. I got half of a pi, so that's 0.5 pi. This is 1 pi. This is 1.5 pi. And then this is 2 pi. Okay? Well, this is negative, so we're going backwards. So notice that it has a half, or I guess you can say like 0.5. So this would, if we're going this way, this would be a negative 0.5 pi down here. A negative half pi. We're not there yet, so we're somewhere down here. Thus, we're definitely in quadrant 4. Now, I can't just go and say, like, oh yeah, quadrant 4, so I'm going to take, 2 pi minus my angle. I don't think I would get the right answer anyways. I need to make this into something like in my first rotation, and then I can find that reference angle, okay? You're going to be surprised by the answer. It's kind of funny. So in order to get, instead of a negative, get a positive for it, I'm going to add 2 pi. Now, pi plus pi, you retain the pi. It's basically 2 minus 0.4 is 1.6 pi positive. Okay, cool. So now we're doing that quadrant 4 formula. And so I'm going to say the 2 pi minus that angle, and I got a 0.4 pi. You know what's funny? It's so similar to the original. I mean, if you think about it, we just went down a little bit, an acute angle, negative. Well, what's that distance? What's that angle here? Well, just absolute value, I guess? Not hard, really, not hard. The last one just says 0.4. 0.4, figure it out. And you're like, what? So 0.4 radians? If you want to know, this is 0, this is 1.57, 3.14. So 0.4 is like somewhere over here, actually, quadrant 1. Where in quadrant 1, if you remember, you don't do anything. That is your answer. The reference angle is the angle that you were using, so 0.4 radians. That's it, you're done. Kind of weird, huh? But because it was weird, I wanted to show you. All right, pull out your unit circle. I don't have one up right now. It's not a big deal. I've memorized it by now. Have you? I wouldn't say it's required, but it's still something I would say is very, 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 very important. Cosecant of this guy is 1 over sine. Same thing. It's just an automatic thing. Where's 240 on my unit circle? It's down over here. And so if you look at the point down here, it's going to be a negative 1/2 negative square root 3 over 2. Okay? But now sine is my y value. And so I've got 1 over the y value, negative square root 3 over 2. That's a good enough answer. If you want to just make it a little bit more simplified, that's fine. You could also rationalize the denominator, but I don't recommend it. 63034. They say find the cosine at 4 pi over 3. Okay. Well, 4 pi over 3, this is, again, 3 pi over 3, right? Pi. So 4 pi over 3 is somewhere down there. Pretty sure. Actually, it's going to be down here. I think it might be the same angle. The same thing? So I got a negative 1/2, negative square root 3 over 2. Again, cosine is my x value. Straight up. There we go. Okay? Pretty easy. 63039. They say that secant of theta is less than 0. My theta is a little bit weird. Hold on. Theta is less than 0. They also say that tangent of theta is greater than 0. and they want to know what quadrant it is in and all that kind of stuff. Well, remember that this is kind of like saying cosine. So my cosine is less than 0. What does that mean? Is that we're going to have a negative x value. It's somewhere over here. Remember that tangent's kind of like slope. My slope is positive. Positive slope means it's going to be in one of these quadrants here, because you know it's going up. Instead of down, down slope looks kind of like that. So positive slope going up. So I got these guys. Well, where do they intersect? It's right there in quadrant 3. I don't actually have a boxed answer for this on my paper. My assumption is just the answer is quadrant 3. So I'm going to just leave that alone and say, there you go, it's quadrant 3. This is a very strange problem, but I'm very sure we talked about something very similar to it earlier. Like, again, chapter 5. They're saying using only cosine theta, rewrite this tangent, knowing that it's also in quadrant 3. Okay? What that means is that my tangent is... Oh. That's why I have a problem here. Okay, so I had an issue with this problem earlier, but I think I'm seeing it, and I think I see the answer now. Okay, forget what I was saying. Okay, yeah, quadrant 3. We're good. We're good. That means we're talking about down here. We have a tangent that's going to end up, in the end, greater than 0. It's going to be a positive in the end, okay? In the end. Now, that doesn't mean anything about what's going on in the meantime. But in the end, I should get a positive answer. We know that tangent is normally written as sine over cosine, y over x, opposite over adjacent, whatever you want to call it. There's just a formula for you. I got the cosine in the bottom. But in the top, I have a sine. There's a formula for this sine. If you remember, it's actually sine squared theta plus cosine. That looks like a bad plus there. Plus cosine squared theta is equal to 1. Well, to solve for sine, I'm going to move my cosine over and square root both sides. So sine is equal to the square root of 1 minus cosine squared. And what I'm going to do is take this and plug that in up there. Therefore, my answer should be square root of 1 minus cosine squared theta all over cosine. But you put this thing in, it says, you're wrong. We are very, very close. I'm going to ask you, is this going to be a positive? Is that ending up being a positive in the end? Because I know I need to be a positive. It's positive slope. Slope is positive. Slope is positive. And the answer is that this is not yet positive. The reason why is we definitely got a positive right there. Okay? For sure. That you square root something without a plus and minus, it's definitely assumed to be a positive. You can't get a negative out of that. So, okay, we got that. Cosine by itself, is this a positive or negative? Well, if you go back into quadrant 3 down here, your cosine is actually going to be negative. This right here is a negative number, so basically it's a negative right there. I got a positive over a negative, which will result in a negative, so it's not positive. I need to have a positive. This right here is negative, but if I change it to be a positive now, positive over positive make it negative, kind of sounds weird. So let me just try to rephrase this in positive language, positive negative language. I got a positive at the top. There's no way I could change that. Right now, with just the cosine, here I'm just going to erase this thing. The way you see it just right here, I got a positive over negative, which should result in a negative. That's not what I want. So what I'm going to do is say, oh, you know what? I can do this. I could put a negative on the bottom. 2 negatives would make a positive. Positive over positive should be a positive, and that's what I want. So all I'm going to do is take the same answer, 1 minus cosine squared, all over cosine. I'm going to toss a minus sign in the front, and there you go. That is a very strange problem. If that's still confusing to you, I understand. I understand. It's one of those wonky, wacky problems. We did something like this back in Chapter 5 with signs and stuff. Here we go again. So if you're super confused, rewind it. You can always, of course, ask me if you like. But ultimately, this kind of problem, If you were to go and get it wrong 3 times, it shows you the answer. You know what to do. Next question. 63049. I've got cosine of theta is equal to 6 over 11. And it says sine of theta is less than 0. Remember, that's going to be negative now. This is actually a positive right here. So also something to kind of keep in mind. Remember, we got adjacent over hypotenuse, or again, x over r, whatever you want to call it there. They're going to want sine, cosine, and tangent, and all that other stuff going down. Well, I got a positive cosine and a negative sine. That's actually going to be down here in quadrant 4, okay? Down here in quadrant 4. This point here, though, I don't know what my xy point is yet, but I can kind of guess. Notice that I have my x, and I have my r. So my x is a 6, and my r is 11. Can I find my y value right here? Yeah, it's Pythagorean theorem. So I'd say 11 squared minus the 6 squared, square root it. Calculator. I got square root of 85. I know that's kind of weird. I don't think it reduces. Maybe it does, I don't know. Square root 85. The problem is that if you're noticing quadrant 4 here, right, quadrant 4, sine is negative. My y, if its sine is negative, my y should be negative. I don't have that. Well, what you do is you simply make it a negative, okay? You know that it's negative. You got a number. Just make sure that's going to be a negative whenever we start doing math, okay? I mean, if you want to see it like a coordinate point, look, we got a positive 6, and we got a negative number going down. Okay, everyone agrees that it should be negative right there. So then I say sine theta is going to be y over r, negative square root 85 over 11. Cosine, he already gave it to us, 6 over 11. Tangent, so again, y over x. So my y is a negative. My x is a positive. And then again, you could flip those guys to get the last 3. Next problem, 63056. They say that theta is equal to pi over 4. Keep in mind, that's 45 degrees, by the way. They want to know, what is sine squared of theta? Okay, well, when they write that square like that, they're really just saying the whole thing squared. So sine of pi over 4, and then all squared. If you go to your unit circle, the y value at 45 degrees is square root 2 over 2. Squaring that guy, I got 2 over 4. Each one of these gets squared, leaving the 1/2. That was pretty easy. Part B is a little different. It says sine of theta squared. Okay, notice that the square is in a different place. I'm saying sine of, and I got this pi over 4 squared. Now, I don't want to say 45 degrees, because if you do 45 squared, it's going to be way crazy. It's not what we're looking for. Pi over 4 squared is actually something like a number in the calculator by itself. Let me go and find it. I don't have my paper here. So I got pi over 4. I'm squaring just that inside. So it's actually 0.61685, da-da-da-da-da-da. You get the idea. I'm not going to just say sine of this and get the answer. I'm actually going to use this in my whole calculator at once. And you're going to get a weird number. I am going to tell you right now, use radian mode. Use radian mode. And the reason why is because, guess what? You got a sign with a radian on the inside. Okay? Radian mode, I put it all in. 0.5784687. There you go. All right. 63059. We have an equilateral triangle, and that should already generate some formulas with sides equal to 14. So I'm going to try to draw an equilateral triangle here. There you go. So I got 14, 14, 14. They say, what's the area? Well, if you go to DuckDuckGo and you go and search it, the area of an equilateral triangle is equal to square root 3 over 4 times s squared. S being your side. I'm sure you can use trig to go and find it, sine, cosine, and tangent, all that kind of stuff. I'm not going to when the answer is something pretty obvious. You're supposed to know how many feet are in a mile, right? 5280. Could you also, on that note card, write down the area formula for an equilateral triangle? Just a thought there. No need to waste time doing sine, cosine, and tangent on that guy. 63063. This is the last question I got. It says, find the area of the shaded region. And it's kind of a weird thing. I got a circle, and I got some kind of arc that is, in this case, 120 degrees, 6 radius. But then they draw a line here. Oh, sorry. They draw a line here, and they shade only this area right here. Find that shaded region. What we're going to have to do is find the, I guess, like the area of the sector. And I'm going to say minus the area of the triangle. Now, that's actually an equilateral triangle. If you could see that, I got 120, I got 6 and 6 right there. That doesn't mean that it kind of looks like a 90 in my case. It's not, it's 120. There is a formula for the, it's not an equilateral, it's isosceles. There it is, isosceles triangle. I don't know what this length is right here, but we got a 6 and a 6, isosceles triangle area, something or other. I went about it a different way, it seems. Okay, so what I did is I drew a little triangle on the side for one of them, like this. Cut it in half, 90 degrees right there. And so if you're cutting that in half, you're actually going to get 60 degrees. So I drew a separate triangle on the side here. And I said, this guy is 60 degrees. That's a 60 degrees right there. And so hypotenuse is definitely 6. This is the x that I'm looking for. Okay, so that's going to be opposite of it, right? And if I could solve for x here, then I can go and like plug it in and all that kind of stuff. So like I can find that length, or I can find the area of a triangle, or who knows what. Actually, yeah, we can, hold on. I got an idea. What if I call this one x and this one y instead? And then the area of a triangle is just 1/2 base times height. That's going to be super easy. Let's do that. So I'm going to solve for x and y individually. Let's go with, solving this guy here, let's go with a sine of the 60 is equal to y over 6, y over r. To solve for y, you do over here, so y is equal to 6 sine of 60. Calculator. Make sure you're in degree mode. I was in radian mode just now, okay? So hold on. Degree mode. Remember, this is like the lecture experience here. Not definitely a perfect recording every time. 5.19615. That's good enough for now. You get the idea. X is equal to, same kind of thing, but I'm going to use a cosine. So I skipped ahead. I basically just, same formula, cosine instead. 6 times the cosine at 60. And I got a 3, just straight up, 3. So that's nice. And so to find this area of this triangle, remember it's like a rectangle. It's, you know, width times length kind of thing. But then half of it. So the area of that triangle is going to be 1/2 of the, well, this guy. You know what? I'm going to do the exact answer for this guy if that's okay. So sine of 60, sine is the bigger one. It's in quadrant 1. It should be square root 3 over 2. So I'm going to say 6 times the square root 3 over 2. 6 and 2 in the bottom cancels, makes a 3, so that's a 3 square root 3, isn't it? I think so. 6 square root 3 over 2. These guys cancel to make a 3 square root 3. Yeah, that's basically what's going on. And so then that's my my y, and then times the 3 for my x. Yes. Okay, yeah, I'm seeing it. This is good. So then I got 9 square root 3 over 2 is the area of that little triangle right here. Okay? Of this triangle. The thing is that that's only 1/2 of the triangle that I'm trying to remove. So I'm going to say, so both triangles are going to be 2 times 9 square root 3 over 2. The 2's cancel, makes 9 square root 3. So I'm going to hold on to that. That's not my final answer, but that's going to be my triangle area, the like super shaded region here that's super dark. My ultimate goal is to find this amount. And so what I'm going to do now is the area of the sector minus the area of that triangle. Okay? Area of a sector is something we've already seen. It's 1/2 theta r squared, right? Remember that theta, it can't be degrees. So if you start doing this thing, it's going to be all wrong. So I've got to convert that 120 degrees first into radians. So 120 times pi over 180. Notice the degree symbols are going to cancel. Basically, it's 2 pi over 3 if you use your unit circle. So that would be pretty easy. And so then I've got now my area would be 1/2, 2 pi over 3. And then my radius is 6 squared. Let's go ahead and find that. My 2's are going to cancel. I got a 36 divided by 3. So 12, I guess, 12 pi. Again, that's like super important there too. So I got this guy and this guy. I'm going to subtract them. So here we go. 12 pi minus 9 square root of 3. That's my exact answer. But decimal-wise is what they're wanting. 22.10654. Gosh, that's a crazy problem. So, like, let's zoom out. Real quick, let's just zoom out and look at it one more time, okay? They're wanting this area of this area, this little section of the area of a sector. It's not the full sector, it's just this little piece. Well, if I say that full piece of pi, my sector, and then I say minus the triangle region, then it should leave that little arc area, okay? See how I'm kind of like cutting it up? Okay, so that's what I'm going to be getting in the end. So my full area of the sector was this guy right here. He was pretty easy to calculate. The area of that triangle is kind of weird, so I went on the side. I mean, you can go to DuckDuckGo, you can go and search it, find the area of an isosceles triangle. I'm sure it's way faster than I did. But eventually, blah, 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 I used sine and cosine and stuff, and I got this guy. So then I just subtract the 2, and we get an answer. Phew! Okay, we're done with that section. That's all it is. I think the next section is going to be like getting pretty interesting and fun. Thank you very much. Have a great day.